Hello everyone, this is Mr. Ahmed Faidi on Artificial Language School, and today inshallah we will start a new video in geometry, parallel and perpendicular vectors. So, parallel vectors, we have vector m and vector n and vector m parallel to vector n. So they have the same direction, and we take vector m on this straight line, the black one, and we take the vector n in another straight line to find the angle which each straight line make with the positive direction of x-axis. So the first straight line, the vector m, make the angle theta 1, and vector n make angle which is theta 2. So if vector m equal x1 and y1 and vector n equals to ordered pair x2 and y2 are two non-zero vectors where m parallel to n. So as we studied before, tan theta 1 equal tan theta 2 because they have the same measure. So tan theta 1 equal tan theta 2. So it's mean we have the first slope equals second slope. So slope of the straight line which carried the vector m have the same slope of the straight line which carried the straight line, the vector n. So the first one is a slope y1 over x1, as we studied, tan theta equal y over x. So tan theta 1 equal y1 over x1, tan theta 2 equals to y2 over x2. So if we make cross multiplication, so y1 multiplied by x2 equals x1 multiplied by y2. So if we take the value or the side x2 y2 to the other side, we'll go with negative sign. So x1 y2 minus x2 y1 equals 0. And this is the condition of parallelism of two vectors, and vice versa. If we have x1 y2 minus x2 y1 equals 0, so the two straight or the two vectors are parallel. So if we have ordered pair x1 multiply y2, which is the multiply of extremes, minus the product of means equals 0, it means the two vectors are parallel. So if x1 y2 minus x2 y1 equals 0, then vector m parallel to vector n. And the perpendicular vectors, we have vector m carried on a straight line and vector n carried on another straight line, and the two straight lines are perpendicular. So the first one make angle with x-axis, positive direction of x-axis theta 1, and second one make another angle which is theta 2, where m and n are perpendicular. Then we said before, tan theta 1 times tan theta 2, if the two straight lines perpendicular, tan theta 1 times tan theta 2 equals negative 1. So tan theta 1 it's mean y1 over x1, and tan theta 2 it's mean y2 over x2. So will be y1 y2 equals cross multiplication will equal negative x1 times x2, negative x1 times x2. This value will be y1 y2 y1 y2, and this value x1 x2. So x1 x2 multiplied by negative 1, so we will get y1 y2 equal negative x1 x2. So we can take negative x1 x2 to the other side with positive sign, so will be x1 x2 plus y1 y2 equals 0, and this is condition of perpendicular, and vice versa. So if we have x1 x2 plus y1 y2 equals 0, so the two vectors m and n are perpendicular vectors. So let's have an example about the parallel and perpendicular vectors. We have vector A represented by ordered pair 2 and 4, and we have vector B represented by ordered pair negative 6 and 3, and vector C represented by ordered pair 4 and 8, then vector A perpendicular to vector B, because we say before the condition of perpendicular, if we have A, this is x1 and this is y1, this is x2, y2. So x1, x2 plus y1, y2 equal 2 times negative 6 plus 4 multiplied by 3, which is equal to negative 12 plus 12, which is equal to 0. So if x1, x2 plus y1, y2 equals to 0, then the two vectors will be perpendicular vectors. And we have vector A is parallel to vector C, because we have 2 multiplied by 8, which is the extremes, 2 times 8, minus 4 multiplied by 4, so 16 times 16 minus 16 equals 0. So we have product of extremes minus product of means equals 0. Then the two vectors are parallel. And we have vector B and vector C are perpendicular, as we said. Negative 6 times 4 plus 3 times 8 equals negative 24 plus 24, which is equal to 0. So vector B and vector C are perpendicular. Another example, if vector A equals 2 ordered pair 2 and 5 represented by 2 and 5, and ordered B represented by k and negative 4, find the value of k when vector A parallel to vector B, and if vector A perpendicular to vector B. So in first case we have vector A parallel to vector B. So the condition of parallelism is 2 times negative 4, which is extremes, 2 times negative 4 minus 5 times k, which is means, equals 0. So 2 times negative 4 minus 5 times k equals 0. And solve this equation. So 2 times negative 4, negative 8. 5 times k will be 5k. So k equals negative 8 over 5. So negative 8 goes to the other side with positive sign. So negative 5k equal positive 8. So k equal negative 8 over 5. Second case, we have a vector A perpendicular to vector B. Then condition of perpendicular is 2 times k plus x1 times x2 plus y1 times y2 equals 0. So x1 will be 2, x2 will be k, plus y1 equal 5, y2 equal negative 4. So 2 times k plus 5 times negative 4 equals 0. So 2k minus 20 equals 0. So k equals to 10. Notice that if we have vector m represented by x and y, and we have k is a scalar quantity belong to R, so k multiplied by the vector m equal k multiply the ordered pair x and y from properties of multiplication. So kx and ky. So if we have m is non-zero vector and k not equal 0, then vector m is equivalent to km. And the norm of km, it's mean the norm of m multiplied by the absolute value of the scalar quantity, which is k. And the direction of km is the same direction of m for every k is bigger than 0. And the direction, so the k is positive quantity, and the direction of km is opposite to the direction of m for every k less than 0. So k is negative quantity, so n will be in opposite direction. Let's have an example. Vector m represented by we have here 2 units, then up 1 unit, so will be 2 and 1. So we have vector a equals 2m. We have vector a equal to m. 2, it's mean 2 multiply 2 times 1 will be 4 and 2. So if we have to find the vector f, we make 2 times vector m. So 2 multiply 2 and 1 will be 4 and 2. Vector B 3m, it's mean 3 multiplied by vector m, which is ordered pair 2 and 1, will be 6 and 3.